Hi, this is Dan Kearney with my Module 6 post-lab video reflection. This week we got to had two experiments. We had an endothermic experiment where we got to make ice cream, which is really fun. And then with our kinetics experiment with yeast and carbon dioxide, we got to see how catalysts work. So yeah, so some safety things that were taken into consideration this week. Definitely PPE, making sure gloves were worn and glasses are insulated glove for the endothermic reaction. Of course, you know, -5 degrees Celsius, pretty cold, so there's some skin reactions to be aware of if those are to go unprotected. Super careful with cleaning and rinsing and re-rinsing of all equipment used this week. I did taste my ice cream. I know some people didn't, but that's okay. Yeah, I wasn't too worried about it. I was pretty confident in my materials. But that was about it, I would say. Disposal, making sure that we weren't putting any hydrogen peroxide in the environment or anything like that. So let's see. So as far as results, everything went mostly according to plan. No issues with setup or kind of the basics of how everything went, but I did see. I almost got ice cream. Probably milkshake. More milkshakey than ice creamy. But the only kind of thing that confused me a little bit was why I didn't see in my kinetics experiment, I didn't see any virtually zero gas produced from my heated hydrogen peroxide. My room temperature one got the biggest. My cooled hydrogen peroxide still inflated the balloon, but not as big. And then my heated one, for some reason, I think I ended up around 61 Celsius at the time that the balloon got on there, and no inflation at all. So I don't know if I did something wrong there. I know it talked about 85 degrees being what you want it to get down to, but then it cooled in the beaker for 15 minutes and got down to 61. So I don't know if I did something wrong there or misread something, but from what I gathered, that should have been the biggest reaction, the biggest gas production of the three. So I'm not sure what went wrong there. Maybe I waited too long to get the balloon on. I feel like I still should have seen some inflation. I don't know. Anyways, what else? We've got so our yeast in that experiment was our catalyst, and catalysts in biochemical experiments are very efficient in that they make it so that a chemical reaction needs less energy for that reaction to start. So a good example of that in the biological world would be probably like that solution that Venus flytraps secrete to break down their food, or our own saliva. It's not just that, but those are good examples. And so I'll turn real quick to my energy diagram here. So I've got energy on the y-axis, reaction progress on the x-axis. You can see here this is our reactants pre-reaction and our products post-reaction. And this kind of shows here's how an uncatalyzed reaction would require this amount of energy before we got to our transition, and how a catalyzed reaction with the use of a catalyst would require much less energy before before that reaction is concluded. And then this this area here shows if it was an exothermic reaction, the heat expelled to surroundings, and if that was an endothermic reaction, it would be heat absorbed by the reactants. So that's what we saw with our yeast. Our yeast was the catalyst in that experiment. And yeah, aside from what I had mentioned about not seeing the heat increase affect the energy output, I don't know. But one thing I do want to add that I forgot to mention earlier is in our endothermic reaction where we made our ice cream, you wanted us to talk about why there was no temperature change once that reaction got going. And the reason for that is that the reactants and the products of that reaction reached equilibrium. So mine got down to about -2 Celsius, and stayed that way for probably 85% of that whole reaction. Like I said in my discussion, you know, I think that process could have been more efficient if we weren't stopping so often to take that temperature, just because, you know, the shaking stops. You open the bag, you put it in, and it's a lot going on, and it takes time that it's exposed to the air before putting your glove back on and closing the bag up, getting all the air out, and continuing that process. So yeah, something to think about. That's all I've got for this week. See you next week. Thanks.